Hello, my name is Martha, and the topic that I picked to discuss is glycolysis. So let's begin. Now, most likely the majority of what I'm consuming is going to be turned into glucose. So quick review, back in chapter 4 of glucose. Glucose is one of the most abundant sugar molecules and is a super high energy source. It's a great energy source. It's known as a simple sugar, and simple sugars are present when we consume carbohydrates. So when I consume my clementine, boom, there we go. And we know that fruits and vegetables are a great source of carbohydrates. And it is a preferred energy source for the brain, especially the brain and the nerve cells, okay? So how do the nutrients, how do what I'm consuming get into the body to be utilized for energy, for how I go about daily life, right? How that's going to happen is it's going to begin with cellular respiration. So cellular respiration is a 3-stage process, and glycolysis is stage 1 of the 3. It's the process that will take the glucose, so it's going to take the clementine that I've eaten and break it down, break the sugars down to get energy from it. The thing about it is that the energy that's there needs to be transferred into ATP in order for it to actually get utilized by the cells. And that's a big deal. And the ATP is so key because the energy that it gives us is how we function, how we move, how we breathe, how we adapt to whatever we're doing daily life-wise, right? So the purpose of glycolysis is to get that process started by taking the energy that we've consumed, the sugar gets broken down, and through an enzymatic reaction of about 10 enzyme reactions with a bunch of big words, and I don't know how to say them, through that process is what's going to yield 4 ATPs at the end of glycolysis, a couple of pyruvate molecules, and an NADH molecules. So what that all means is that when we eat, when the sugars get broken down, our body needs the sugars, the energy, to be in the form of ATP in order for the energy to go into the cells, in order for the cells to do the normal things that we do on a daily basis, not just for when we need them to go do a super high intensity workout, but just to function on a daily basis, to breathe, to sit there and breathe. Our body needs energy to do that. Speaking of high intensity workouts, what's happening to our body while that's happening is the oxygen that's in the muscles gets depleted. And so in order for this process, this ATP process to still happen, that's where those pyruvates come into play. So the pyruvates, through a process of fermentation, they're going to create lactic acid in the muscles. So the muscles have some oxygen, some energy to, not oxygen, but so the muscles have energy to continue on doing, if you're doing a super high intensity, super sweaty workout, that's what's going to provide you the energy to continue to do that. You don't have oxygen. Our bodies need oxygen, right? But that is kind of the gray area for how this process is still going to happen and still produce ATP and still produce the energy that we need because of that second kind of part of glycolysis. So even though you can't breathe and you have, you still have more to do, your body's going to give you that in that process. The other 2 stages after glycolysis definitely need oxygen. So they are aerobic, and glycolysis is an anaerobic metabolic pathway. And that's pretty much about it as far as, at least what I think the highlights are, why glycolysis is important to understand because of what it's going to do as it goes through, as your body goes through to create ATP. So by the end of the cellular respiration process overall, once it goes through all 3 stages, you have 30 plus ATPs that have been made. And so this process is continuing. It's happening all the time. Do you feel it? So hopefully this was helpful, and have a good day.